All right, so this is how you're going to do the lab. Okay, so you need to open it up. It's called Newton's second law. All right, and then hopefully you're watching this video. All right, so answer these questions first after you look at the video. Okay, so let's take a look at it. Getting started, whatever. Okay, so here's the video. All right, so basically you want to start with it like this. So if you just kind of watch it, what's happening is they're turning on this fan, okay, which is sort of levitating this cart a little bit, okay, right? And it's also blowing air out to the left, okay? So when I look at this, right, so see now they've stretched it, and then the guy's going to cut the string, okay? And so the fan is pushing air to the left, all right? So I want you to think about if the fan pushes air to the left, what's the Newton's third law pair force, okay? And then we're going to try to find the relationship between mass and acceleration, okay? So you want to choose a constant force that you're going to keep, all right? So let's reset. Okay, so basically, see fan force, you can pick 1, 2, 3, 4, or 5, and we want to keep that constant the whole time, okay? So choose whichever one you want to use. It does not matter, okay? And I guess you hit load or whatever. Okay, right? So you need to have the value of that fan force. So basically, they've kind of created this little ruler that measures in newtons. Okay, well, yeah, okay, right? And then we're going to hit play. Okay, so then watch. Look, see, once it gets stretched, see how it looks different now? Okay, we want to go back to where it's not stretched, and you want to try to find out how many newtons it is after they pull it. Okay, so if I put my 0 in whatever place you want, or you can put it like, you know, whatever, it doesn't matter. Okay, and then once it stretches, right, now I can read that that force that the spring has, right? So the force that the spring is being pulled is the same as the fan is being pushed, right? So those are going to be equal and opposite because it's not moving at this point as it's stretched, okay? Once you get that force measurement, that's all you need. You don't need to do that one anymore, okay? All right, so then what you need to do is you need to, I'm going to turn that one off, okay? So once you have that value, you want to keep that the same the whole time, okay? And then if you have mass and acceleration, you need to think about which one is the one that I can actually change and select the number for, okay? Right, so based on these videos, you can see, well, it's not giving me acceleration. I only have a choice of different masses. Okay, so you're going to choose a different mass, all right? So each time you'll choose a different mass, okay? And then once it cuts, so you can see on the top, like the exact second that it cuts, all right? You want to measure the acceleration after that. Okay, so let me go back. So see, I'm going to try to find the exact moment that it's cut. Okay, and you have a centimeter ruler, all right, and you have a timer. So you need to think about what do you want to measure so that you can calculate the acceleration, okay? You just need to measure one of each and you should be able to calculate the acceleration, all right? So this is not, the position and time is not the part that you're going to graph, okay? So you can move this ruler however you see fit, okay? Just make sure that as soon as you, as soon as you cut the string, right, the instant that the string gets cut, okay, click. Okay, well, there it is, okay, right? As soon as the string gets cut, right, and now the spring is moving, that's where you want to reset your timer to 0, okay? All right, and then I'm going to leave it up to you to figure out how to calculate the acceleration, okay? And before the hand hits it, once the hand starts slowing it down, that's a different thing, okay? So we just want that kind of time on the track, all right? All right, so once you get that, then you can switch the mass. Don't change the force, switch the mass. Okay, do it again, right? Switch the mass, etc. Load. Okay, do it again, switch the mass. Oops, I meant to hit play. Okay, do it again, okay? Right, so you're gonna have to move your stuff and reset your timer, you know, whatever, wherever you need to set it, okay? All right, so you're gonna measure that position and time, figure out how to find acceleration, okay? And then you need to figure out what you're gonna put in your data table, all right? So put the titles up at the top here, all right? And I want you to mark down everything that you measure, okay? So mark down everything that you measure first, and then in the remaining columns, anything that you need to calculate, you can make a new calculated column, all right? So you can go ahead and do that, all right? Once you do that, okay, then I want you to graph acceleration on the Y versus mass on the X, all right? Include a trend line. And this is a new shape that we haven't used yet, okay? So you might need to think about it or kind of check in with me. Hopefully I can do that for you and see what the trend line is going to be. Okay, make sure you label it, whatever. Answer the questions. Okay, and then I want you to practice linearizing it because that's a common skill in the AP test. So then we did this a while ago with acceleration. Manipulate the x-axis data, all right, so that then it graphs as a straight line. So you really need to think about what that's going to look like, and then I want you to write all the equations and the y-intercept for that. Okay, all right, once you finish all that, then come back and then I'll do another wrap-up video about what you should find.